Assalamualaikum students, welcome to another video, and today's our topic is all revision of first chapter. So first of all, going with the definition of energy. So it is defined as that ability to do work is called energy. Okay, it's called energy. And then we are having the definition of force. So it is defined as a force is a pull or push, or you may define as it is a tendency to change or try to change the state of any object. Okay, now we are having the definition of science, which is more common, and the definition of science is to know about the nature, to get information, to get means knowledge about the nature. That's called science, to know about the nature. And the definition of physics is the interaction, the study of it is a branch of science which deals with the study of matter and interaction between matter and energy. Okay, so these are small definitions which are also important. So here we are having the definition of matter. It is defined as anything which occupies space and having a mass. Is called matter. Okay, so now we are having the definition, the topic physical quantities. PQ stands for physical quantities. So all those quantities which are measurable, called physical quantities. So there are three types of physical quantity. One is fundamental physical quantity, can be write as sub physical quantities or fundamental physical quantity, and the other one is derived quantities, and the third one is tensor quantities. So all those quantities which are having which do not need any other quantity to derive it, needs no other quantity to drive them. Okay, and the example of sub-fundamental quantity is mass, and whose unit is kg, and the units in sub-fundamental quantities are known as fundamental units. Okay, and then we are having drive quantities. It needs quantity, and needs two or more than more sub fundamental quantities fundamental quantities are required to drive are called drive quantities. Okay, so the example of drive quantity is force. Mass is having its units kg, and the acceleration is meter per second, and this one acceleration is also a drive quantity. Okay, so here we are having this one tensor quantity, the quantities which are having direction plus magnitude, both magnitude, but they are uh, still called as scalar quantities. Scalar quantities are known as tensor quantities. Okay, so the example of tensor quantity is, for example, charge. Charge is having direction, magnitude both, but is still calculated in scalar. So that's why the quantities which are having magnitude, direction, but they are again scalar, so we calculate them in tensor quantities. Okay, so now we are having the dimension topic. It is the most important topic. So the dimension of meter is L, and dimension of second is T, and if we this T will be going there, it will be become inverse. So this is the dimension of velocity. So we are having the dimension of acceleration. So if we want to drive it, then it will be simply acceleration equals to meter per second square, and the meter is L here, and second is T here, T square. When this T will be moving towards upside, then it will become T minus 2. So it is the dimension of acceleration. So we are having the dimension of kinetic energy. Formula for kinetic energy is half mv square, okay, equals to kinetic energy. So numbers are neglected in dimensions. So mass, the unit of the dimension of mass is capital M, and the dimension of velocity is LT inverse. So we will be writing here M LT inverse equals to kinetic energy. So kinetic energy, the dimension for kinetic energy equals to M L T inverse. It is the dimension of kinetic energy. So now we are having the dimension of power, which is equals to power equal to work upon time, and the means dimension for work is, first of all we need to calculate the dimension of work. So here we are having the dimension of work. The formula for dimension of work is F into T, and for this we need to calculate the dimension of force. So force is equal to ma, and the dimension for mass is m, and the dimension for acceleration, here we have lt inverse 2. So the dimension of force is equals to mlt minus 2. So here we are having force. So for the dimension for force equals to force equal mlt minus 2, and the dimension for distance equals to L. So it will become work equals to m L square T minus 2. T minus 2 is the dimension of work. So now we are going towards the dimension of power, which is equals to m L square T minus 2 will be in the numerator side, and L square T minus 2 upon T. Okay, when this T will be moving upside, then it will become minus, and the power of T will become minus, then it will become minus 3. So it is the dimension of power. P equals to, this is the dimension of power. Okay, so now we are having the dimension, wait, this was the potential energy, but now we are converting it into power. Okay, so the dimension of potential energy will be here. Okay, energy. Okay, by mistake I have done the dimension of power here. Okay, so that's why I will be doing the dimension of potential energy here. The formula for potential energy equals to mgh, and the mass, the dimension of mass is m, dimension of gravity due to acceleration is m is lt minus 2, and the dimension for height is again L. So it will be equals to, putting this all values in this equation 1. Okay, putting the value of m and g and h in equation 1. Okay, so then it will become m, and the dimension of g is lt, and L square, it will become L square because L will be multiplying, and the dimension of T will be exact here minus 2. Okay, so this is the dimension of potential energy, because m equals to mass, gravity equals to lt minus 2, and this one h will multiply it with this. For example, there is 1 and there is one more L, then it will become m L square T minus 2, and this is the dimension of potential energy. Okay, so do not get confused. So now here we are having the dimension of equation of first equation of motion. So Vf equal to Vi plus At. First of all, the dimension of velocity is L upon T, because meter per second, and L upon T here is plus L upon T square into T. So this T will be cancelling with 1 is T here, and this will become L upon T equals to L upon T plus L upon T. Okay, so when we will be taking the LCM, then it will become T L plus L 2L upon T equals to 2L upon T. So numbers are neglected, and numbers are neglected in dimension, so it will become L T inverse equals to L T inverse. So this is the dimension of equation of motion, and here we are having the dimension of second dimension of equation of motion, which is equal S is equal to VIT plus half AT square, and the dimension for distance is L, because its end length equals to, and the dimension for velocity is L upon T into T for time, and numbers are neglected, so that's why we will not be writing. So L upon T square into T square, so this T square will be cancelling with this is T square, and this T will be cancelling with this. So L equals to L 2L, L plus L 2L. Okay, so now we are having the dimension which is equals to L equals to L, and now the numbers are neglected, 2 will be neglected. So now we are having the topic of rules of rounding of data. So if there is a number which is having which is greater than 5, for example 1.837778, So these three, if we have to convert it into 3, then this 8 will be dropped, but it will add here. Okay, so the numbers which are greater than 5, greater than 5 sorry greater than number greater than 5, then they will be adding 1 in next and then simply drop. Then for example, it will become 8 and it will drop, and this one will, when this one will be dropped, then it will become 8. So now it will become 1.83. okay, so 1.838, then it will, when it will drop, then it will add here 1.84. So if we this is the first rule of dimension. If the number is greater than 5, then we have to add 1 in next and then simply drop it. Okay, so the other one rule for dimension is, if a number is less than 5, then simply drop. For example, 9.3241. So it is less than 5, less than 5, less than 5, less than 5. 9 is the answer. Okay, so these two are the rules of rounding of data. But we are having the third one, which is only for 5. If the number is equals to if the number is equals to 5, if the number is equals to 5, and if that number is even, then we simply drop it. Simply drop. If the number is 5 and the next number is even, then we will be dropping. And if the number is odd and the next one number is, if the number is equals to 5 and the next one number is odd, then we will be adding 1 and then drop. So the example of this one is 1.6, example of odd. Okay, I am giving only the example of odd. 1.6 1.65 1.65. okay, the okay, this is the example of even, not odd. So when the 5 will be dropping, then it will be adding, it will not be adding anything, because 6 is an even number, so it will become 1.6. okay, so now we are having the example of odd here. The number is like this: 1.773 and 5. Then when it will be dropping, it will be adding 1 here, so it will become 1.74. okay, so now we are having the examples of addition, subtraction, multiplication, division in SF. So 1.632 multiplied by this 1.1632 multiplied by 032. Point is after, before 1 2 3, and here point is 1 2. So 3 plus 2, we have to we have to means we have to note that point after 5 digits. okay, so when we will be multiplying it, then it will become 2 2s are 4, 2 3s are 6, 2 6s are 12, 2 1s are 2, plus 1 3, 3 2s are 6, 3 3s are 9, 3 6 are 18, plus 1, 3 1s are 3, plus 1 4. Then it will become 0 0 0 0. What the hell? 0 0 0 and then 0. okay, then we will be adding 4 6 6 12, 1 will be going there, 3 and plus 9, it will become 9 10 and 12, 1 will be going there, then 4 8 9 12, 12 plus 0 equals to 12. Okay, so 1 will be going there. 4 plus 0, 4 plus 1 equals to 5, and 0 0, and 0 will be here. Okay, so when we will be putting point after 5 for 1 2 3 4 5, so the answer of this one is here. But for multiplication and division we took least SF. Okay, so here the least SF number is 3, so we have to give answer in 3 numbers. Okay, so 4 will be dropping, 2 will be dropping because they are less than 5, and this one 2 will also drop, so it will become 0.52, and which is the answer. Okay, so now we are having this one, so I'm making a bit of a space here also, so we will be doing clearly. Okay, 36.12 divided by 6, 6 ones are 6, 6 6 are 36, and 0.12 multiplied by 6, 6 ones are 6, 6 twos are 12, 0.1, 0.2. Okay, so it will become 6.02. 6.02 will be the answer of 36.12 divided by 6. Okay, so we have to give answer in one SF, because the least SF here is 1, so it will simply drop, and it will become 6. So it is the answer of 36.12 divided by 6 in SF. So here we are having another one topic from 482 at 3.9. So 2 8 9 9 plus 8, it will become 17. 7 1 4 and plus 1 5.4. so we have to give answer in one SF after decimal. First of all, I need to create the rule of addition. So the rule for addition is this, that if there is a number 1.482 and the other one is 3.9, and they both are adding or subtracting, then we will be looking at the number after the decimal point. Okay, so here we are having only one SF, and here we are having 3 SF, so we have to give answer in least SF after decimal point. So okay, so this 2 will be dropping, 7 is greater than 5, it will be adding here, then it will become 4.6, and this is the answer of this one question. Okay, so here we are having 15.84 2.673. We have to give answer in least SF, so here we are having 2 and here we are having 3, so we will be given answer in 3. Okay, in 2, 3, 4 plus 7 equals to 11, 9, 10, 11, 12, 13, 14, 15. 1 will be going there, 6, 7, 8, 1. We have to give answer in 2 SF. It will simply drop, 1 will simply drop, 18.5, 18.5, 1 will not be dropping. Okay, 18.51, because we have to give answer in 2 values. Okay, after decimal point. Okay, so this was our topic, and see you guys in the next video.